Hello and welcome to the YouTube Accelerometer project. Our project came from homework set number 1. In this problem, we had to do a derivation of an acceleration equation where we used a U-tube to determine the acceleration of a vehicle in the x direction. From this derivation, we were able to show that acceleration in the x direction is a product of the acceleration of gravity times the height of the displacement of water divided by the length of the U-tube. For this project, we wanted to measure the accuracy of this equation and experimental setup. For our experiment, we used a 2010 Volkswagen Passat as our vehicle to test the acceleration. From the internet, we were able to gather data on what the acceleration of the vehicle was from 0 to 60 miles per hour. From this, we were able to gather information on what the height to length ratio should be of the tube. From here, we decided that a good size would be a length of 19 inches for the tube, which would equate to 6 inches of displacement of the water, while allowing our U-tube to fit in the car. For safety factors, we ended up making the height of the tube 12 inches so that water would not spill out. Here is a photo of our experimental setup. We use clear PVC with elbows constructed in a U shape. We use a rigid plywood base to prevent the tubing structure from moving. The Volkswagen Passat ended up accelerating from 0 to 40 miles per hour on the 27th Street Bridge. We used a GoPro for video analysis. We had a fair number of assumptions in doing this project. The first assumption was the road that was level at all time. If the road was not level, it could affect the water displacement in the tube, which would change the acceleration reading. A second assumption was that the car acceleration was constant. If the car acceleration wasn't constant, we would have varying heights of our water over the 0 to 40 miles per hour. A few other assumptions were that the water was Newtonian, the density of the water did not matter, the tube was frictionless, and that all our video measurements were perfect. Here is a video of our project in action. As you can see, the tube on the left-hand side has the water decrease in height, while the tube on the right-hand side has the water increase in height. We used a red food coloring on the left-hand side to be able to better see the water displacement. Our results were fairly similar for both the timed measurements and the measured acceleration from the U-tube. We were able to show that the car acceleration from a timer was 3.44 meters per second, while the acceleration from the U-tube was 3.35 millimeters per second. We were able to show that these numbers were not significantly different using a t-test, but there were bigger differences in the variability of the car acceleration. The reason for this could be because of a few sources of error due to our assumptions. One source of error was our video measurements were not perfect. A GoPro causes a fisheye effect, and in flattening the video, we most likely distorted the video to some degree. We also had the video be slightly shaky due to the acceleration of driving and bumps on the road, and the car did not accelerate linearly, so we had to determine the best moment to take the recording from the video for our measurement. Thank you very much.